Welcome to the Code of Entry podcast, where we cloud the issues with facts and help you upskill to stay on the digital edge. Here's your host, Greg, with the latest.
Hey team, Greg here with another Code of Entry podcast. I've got Keri back. So last time we talked about data literacy, and I'm pretty sure our plan was to have one episode on data literacy, but then somebody, might have been me, decided to keep ranting about different topics. So we're back for part 2 to continue on data literacy. Yeah, it's hard to recap all the random things we talked about last time. Data feeds, data governance, learn by doing, the 4 V's of big data becoming the 5 V's if you add value on the end. Talking about trying to find that balance between not being the person that's, but we've already tried that, and still needing to innovate, but also trying to push people not to repeat mistakes of the past when they think they have a new idea that's not new.
Yeah.
With that said, I'll hand it back to Keri to drive the discussion forward. And today I will try not to get on as many different tangents. Keri.
Those are usually pretty entertaining whenever you get on the tangents.
Yeah, for you, but not for my blood pressure.
That's true. So I think last time we went down the rabbit hole after big data with the 5 V's. So I want to recap at least where we're at for the types of V's that are out there. So we did a good deep dive on a volume of data, then we went into storage. Then we talked a little bit about velocity of the data, which would be speed at which the data is created, collected, or processed. And we talked about real time or near real time and talking about those use cases. I don't think we talked as much about variety.
Yeah.
So I think we'll talk a little bit about that today. So the type and nature of that type of data. Fourth one is veracity. So quality and accuracy of the data. I think we talked about that kind of, it's been woven into the conversation the whole time when we're talking about identifying the problem and finding the right data to answer that question. And then the last one is the value part, which is added not recently, but originally it was just 4. Now with the value part, it actually helps with what does it mean to have that type of data to help make decisions? And if it's valuable enough and useful enough, then do you make it a priority to make sure you always have those data sets coming in?
Yeah, and I think that 5th V kind of got added when you went past the data scientist, kind of people doing things with data because data is their job and they just want data, to trying to make sure that there's a business outcome or decision that the data is driving on. How does that, so as you start talking data literacy, that 5th V is really added on to hammer home the point of there's got to be a reason for this data. There has to be a reason for what you're doing. It's not just data for data's sake.
Well, I think it's also the different work role that you might have on your team. And the data scientists and the engineers can help with the veracity of the data, right? The quality, accuracy, certain percentages, they get down to the statistics and start providing that information. But how do you translate that to a decision maker for value? Sometimes we miss that piece, and it's not inherent. Like we're going to do our data science job. We're going to go and science all of the data and get a good probability and have a percentage. But you have to translate it more into usefulness. So what does that mean to somebody that needs to use whatever project value that you have?
Yeah, and it helps communicate value a couple ways. One is the value of your data scientist, your data science team, because you need some people that can do the math, some people that can do the engineering, some people that can take those things and translate them into why it's important. But then the other side is what's the business value, so you can get investment into that team too.
Yeah. So I think the accuracy of the data depends on the data you're trying to go after, which would be the variety. So could we talk about a little bit of structured and unstructured data?
Sure. So there's a lot of people that think they have unstructured data that have structured data, and they just don't understand it. So there will be things like in network traffic. Oh, we have all this unstructured data. Not really. If it's a syslog, it's unstructured, but once you figure out what the schema is once, it's now structured. JSON documents, very structured. CSV, structured. XML, structured. Almost any log file, structured. You start getting into PDFs or free text from a customer support ticket, yes, unstructured. And then there's things you can do to structure that, right? So you start going through it and using computer vision to pull out things. I use just regular text recognition like OCR and pulling the text out and making it data. You can start to resolve, okay, different fields start with this, or we trained people to always use this phrase or whatever. Once you start pulling the data out, you can start to structure it some, but there's also algorithms that kind of lend towards evaluating unstructured information. I think the interesting thing for dealing with that variety is you don't have to solve that problem yourself. And that's why I make the push for data platforms. It's as a web developer or a user, don't worry about the data. Let the data engineer worry about the data. Don't worry about what data store are you going to use to store this. You need to have an API that you can hit to get access to whatever information you need, and let a data scientist and data engineer figure out exactly what types of data store that's stored in and how that data is interpreted, stored, indexed for use in a way that's useful to users and app developers. So I think it's, people be like, oh, you're using an SQL database. That means you can't do X. We might have other data stores that you don't know about. It's not your job. It's okay. We'll make sure that there's data stores available. Or if you have a system that doesn't support multiple data stores, you might be doing the wrong thing. Or it might be time to go to an object store. A lot of transitions have been done going into object store. And I'll just, hey, let's put it in Blob or S3 and evaluate it from there. That's kind of much more possible that now it deals with a lot of variety. So I think the variety discussion, the interesting thing for having the variety discussion is just trying to have that maybe broad conversation about the different types of people they are and what variety implies to them. Because variety to an app developer, you might say, hey, I need this structured and then it's unstructured. That means I want to have all these different tools I need to pull from. No, not necessarily. There should be a middleware layer that you're hitting, that someone's managing to make your job easier. And that comes back to having a team of people try to respond to a problem and not do everything yourself individually. It's hard to have people that have that full stack experience. That's why they get paid a lot of money. Those unicorns are few and far between though. So build your data science team. Everybody will get better. Have them talk to users. Have data literacy training so folks know what kind of the state of the art is. And today that state of the art is, chances are if you have data, it's not too big. If you have a variety of data, it's not that hard to handle. If you're naming databases and you're not the database expert, you're wrong. There's just it needs to be a team, because one of my old pet peeves was you'd be talking to this leader that's trying to sharpshoot you on, I think you really need a graph database for this. Be like, oh yeah, really? How have you tried to implement this? I haven't, but I know you need graph. And be like, oh, I don't think you do, because here's the answer. This is going to be too much data for you to store. You've never stored this much data before. And be like, actually, this is less than 1 day of the system that we normally manage. This is all you've got? So it's just, there's a lot of people that don't know what they don't know and assume that they're experts. And that comes back to, hey, the value in that 5th V, hey, data literacy training adds value because you help move that bar of understanding. So hopefully you have relevant conversations and you don't spend time having some of those frustrating ones.
I think the part I like on like giving tips and tricks related to a variety of data is the going against the assumption that every attribute you have for whatever data set you're looking at will be in one table or one file. When really it'll be multiple files that you can work with the data engineer on to actually correlate and make one good data view for it. So if you're looking for something that one file has last name, first name, middle initial, your social security number, if that's the case, points of contact information, emails, things like that. Okay, that's one data set. But then there's another data set that tells your work location. It has whatever type of information you have for your laptop, if you have different devices, personal electronic devices, phones, whatever it looks like. And it can actually just be correlated together and put into one data set. So that variety, whether it's dynamic, static, or other things that are being logged for your system that are monitoring you from point A to point B, those can all be put together. And that's different types of, I'd like to highlight as varieties as well.
Yeah, and another interesting point on that's where our expert's going to be like, oh, you're just joining the data. Deep breath. Hey, you're not necessarily always joining that data. We used to call them analytic focused data sets. Then we started calling them nucleus data sets, and now they're data products. You might be creating a data product, but if you're not using a relational database, you might not actually be joining. The way that HDFS works is It's kind of like how my brain works. If I'm going to sort my clothes, I'm going to just lay them all out on a flat surface and be able to look around and pick what I want. It's one big flat file. The way a relational database works, I'm going to have to go like one drawer at a time and figure out where it was folded and put it away and find the one that I want. And that's a way. But you have to take things from each drawer and join them. It's just, a different technological approach. Then you're doing a join. But in a lot of these other structures, join isn't really the right construct. So it's more computationally expensive or whatever. So I think, hey, if there's information down there, it can be correlated, it can be stored. If you're going to use it more than once, it can be stored in a data product. If it's just going to be used more than once, but in a single computational effort, you probably just put it in Spark and hold it in memory. If you're only going to use it once, then, hey, let's use MapReduce and pull it up once and then reduce it. So there's a lot of technical approaches, but it comes back to that team. You need an expert if you're going to do something repeatedly to make sure you do it right.
So I think it transitions a little bit into the analytics portion of it, when there's different types that are out there. And as part of your team construct, you'd be asking a data analyst. You can get a little bit of the information out of the data engineers. You can ask your data scientists, those that might be doing business intelligence, on what are they trying to analyze from these data sets. Do they need to have the different types of data stores that you're talking about? Can they run more analytics after that for post-processing, after it's already been saved to disk? Should they save it somewhere else? Is it just going to be in their notebook-like capability? Those are some of the things we want to talk about when it comes down to techniques. I just want to go through, at least definition-wise. You have different techniques where it could be descriptive analytics, so saying what happened. You have diagnostic analytics, why something happened. You'll have predictive analytics, what's likely to happen. This is what we talked a little bit about, probability and percentages for that. And then you have prescriptive analytics, which is what should be done. Makes me feel more things. If it's prescriptive, what should be done could possibly be automated in the future, especially for actions being taken, whether it's network related or anything else related. So I guess going back to more of the techniques of descriptive analytics, knowing that you have lots of data, different types of it, you're trying to provide more information to your senior leaders of, hey, I have the problem, I have whatever question I'm trying to answer. What's my best technique to answer that question? What kind of analytics?
Yeah, I think there's a couple angles to look at it. One is emerging analytic capabilities. Hey, we just started trying to make data-driven decisions. So we just started collecting information, and I've got to answer questions, and it's ad hoc right now. This might be the first time, might be the second time. Then a lot of your descriptive analytics are going to be notebook style or Lucene searches or SQL searches to the data, and they're going to bring numbers back. And I think the important thing is trying to figure out how to explain how you got to that number, but also explaining, maybe visualizing that number in a useful way. So you don't want to run an analytic and come back, well, the p-value is 0.02. And the decision makers, okay, so what should we do? They're like, the P's 0.02.
Yes.
Okay, thanks. Next slide, next briefer.
Right.
It's not hey, it's 0.02. It's, hey, we have 98% confidence that the network is going to go down because of this. Oh, hey, thanks. Let's fix that. So I think that's the first thing. The next angle is, while as you mature doing that, you've got to get to an ecosystem to where your average/beginner users can see day-to-day value, so that they're not lobbying for other things. They're not lobbying to spend money on different things. You get user adoption for what you're building and trying to do. You can't change the culture when the average people don't see the value. So then you have to start working on descriptive analytics that are part of apps. And I think I've drawn out this nuance before, but just arbitrarily, what's the difference between an analytic and an app? Because the word analytic gets vastly overused. Analytic, any type of kung fu you're doing, whether it's a query in a search window or some few hundred lines of code that you've made that do the greatest thing ever, good for you, still an analytic. If it's one or more analytics that are put together with a custom user interface, then you've got an app. And that's where you're going to get after kind of average users. In the background, whatever magic you've made happen is happening, and they get a blinky red light that something's wrong. Or they get a score every day saying how they're doing. And if their score falls below 70, they're failing and they need to do something. Still descriptive though, because it's just an update based off information describing. It's not telling you maybe exactly what's wrong. It's not telling you what you should do, but it helps make your life easier. It helps you get after that first step. So I think it's the first step. It helps you build user buy-in. It helps you start making data-driven decisions. It helps you start getting more and more data so you can get more advanced, because that's probably the Achilles heel of most data and analytics efforts. It's somebody being like, I want it. Great. We all want AI. What data do you have to put in? We don't have any. That's what you're going to use the AI for. That's not how this works. Well, just use somebody else's data. Then that's really not going to work. It's not applied to your business. It's not applied to your use case. Yeah, sorry.
I think on the descriptive analytics, what I had found is I'm trying to answer the question with whatever the data I have, but I'm missing some fields that will help me get a better percentage of confidence. So the higher confidence. And so that includes me having to go and asking if I have other data sets at other locations, or if I can find something else that I can use for enrichment to give more value, so that when I am trying to describe it to the senior leader or whoever is part of the decision-making process, I try to find the details of the questions they're probably going to ask me already. And if it's not in the data, at least I need to be able to say that. I don't have access to that data. It would be good to have it. I think we could go through the next X, Y, or Z types of TTPs, different procedures that can help enhance it next time. So like a ticket. I didn't have like good, bad, benign, unknown. I didn't have all those little attributes, but the next time I have somebody create a ticket for a standard, I want them to fill it out. And that would be helpful later on.
Yeah. So you anticipate questions, and if you have data gaps, identify that, but don't just say, I don't have enough data. And be like, I didn't have the data that was needed. After analysis, we decided that in every ticket, if we put this one drop down in, we could answer this next time. But we started coordinating to have that added. Sir, ma'am, if you'd like to tag in and support that, it would help it get implemented. They'd be like, absolutely, right?
Yeah. I think what I would translate it into for leaders is a part of your collection strategy or your sensor strategy, because you can collect via human-enabled information, and then if you need to tweak a sensor to collect that information as well, it can go back into that cycle. For me rambling on for the other pieces, for example. All right, so we covered a little bit about descriptive. Can we talk a little bit about predictive analytics? I know you did the 98% piece.
Yeah, predictive analytics end up being hard. Yeah, if you're talking network data, they become very hard. You can start maybe doing some prediction based off seasonality, different trends over time or time of day. You can also start doing some kind of user activity monitoring kind of things to get predictive, being like, hey, this person only ever works from 9 to 5, and there's logins in the middle of the night, and they're on the other side of the world. So you can start doing some analysis there. I think that, highly debatable, but I think the easiest way to get after predictive from a cyber network perspective is trying to fuse data from as many places as possible and bring in those open source threat indicators to see what's happening in the rest of the world. You can start trying to look at virus total and be like, hey, what are the things that are out there that are exploits? Can I map those to vulnerabilities? Okay, these vulnerabilities have these exploits. These have been reported somewhere else in the world, but we haven't seen them on our network yet. Probably going to come to us. So let's start looking. Or other militaries have this, and that becomes hard, but other militaries have this thing happening. So I think sticking commercial helps a lot. If you're in the commercial side, yeah, just paying attention to indicators from other companies helps you get predictive. And that's just looking at defense. Now, health and stuff, there's a lot of information you can look at on machines and just start going back. And you can train a data set based simply off of, hey, this machine failed. Go back and look at the logs, what happened before that machine failed. And maybe there's a pattern that that model finds over time that you didn't see. Hey, normally the temperature starts to spike, but before the temperature spike, this other sensor started, the fan speed started to malfunction because the machine was vibrating or whatever it was, right? That information's available. So I think that the predictive side starts getting much better when you can do some supervised learning. Unsupervised learning, depending on your use case, that can be reliable too. But going back to starting, I think unsupervised learning can give you a false sense of confidence, and it's harder to explain. So if you can kind of broach in with supervised, then reinforced, then unsupervised, I think you can apply to more and more data, but it's less explainable. So you've got to build that comfort.
I think the We talked a little bit about the variety of data, structured, unstructured. I think data that you can enrich or enhance that has some sort of numeric value that can help provide that predictive piece of it is a key thing. So we have to say some of the problems were harder to solve because you couldn't just take something that was unstructured, which was like, I like it, I don't like it. Is it a 1? Is it a 2? Is it a 10? Liking it, what does that mean on a scale? Trying to put something into a numeric value. And then maybe for me, it would be, okay, if there's a count of whatever the activity is per day, is there a spike in that count? And if there's a spike in that count, is it once a week? Is it every Tuesday because everyone is downloading the different podcasts? Is it on a Friday?
Yeah, it was a
Because
Tuesday because everyone was downloading the Code of Entry
I
podcast.
think
It comes out on Tuesday. Yeah.
finding all the different data points with some sort of numeric, there's a metric to it. And then if you need to do more of the adding in more knowledge or why factors, right? Why things might have happened. So why is there a spike in social media at a certain time of the day? Is there a spike before large activities that are happening in the Middle East or in the Asian Pacific area? There's other things that are like current events happening, but the data that you might only see only matches something that's a little bit more unstructured that doesn't have that numeric value. So you can't really get into the predictive right away. You might have to do more things to it so that you can get to predictive, and then maybe you just check on it later, see if it actually came true.
Yeah, and I mean, I think a problem that I have, a preconceived notion over time that's built up is been dealing we've been on the cutting edge. We've been dealing with huge volumes of data. There aren't a lot of models that someone else has made that we could rely on. There weren't packages that already existed. So I think if you're out there and you're at a small business, medium business, and you're doing some things that aren't cutting edge, it doesn't mean they're not valuable, but they're not cutting edge. You can probably find a package or a model that helps. Hey, start Googling, get on Stack Overflow, ask ChatGPT, what's in it, 4040, which is now out now. Just do some research. See if you find something that, even if it's not perfect, it's better than what you're doing. You can learn from it. Because we always defer to, it doesn't exist yet. We'll have to find it. The larger the volume of data you have, the other challenge is whatever algorithms you can find don't necessarily scale, right? Like a really simple way to do predictions is a Monte Carlo simulation. You can't do a Monte Carlo simulation on the volumes of data that we're used to. But hey, if you're working and trying to, optimize a problem at a small business that rents out cars or whatever, it's probably completely appropriate. We don't necessarily always, well, they said you can't do it. Okay. Sometimes I'm biased, so I need to point that out.
Yeah, I think a lot of the examples would be stats from baseball. They do a lot of those as, okay, you want to dip your feet into predictive analytics? Let's start with this type of data set, and you can start running all the different models. And then you have outputs that you can match up to, like making sure you're reinforcing that you're doing the right techniques. And then you get into something that's out of those metrics, let's say there's 100, 200 rows, right? And then you get into something that's like 1,000,000 rows. And if you have a 1% false positive, that's a lot of rows to try to go through later and fix. Scale is a thing.
Yeah. So start small and grow, whether it's just learning or starting to apply it. Just going from baseball to football is like exponential data growth because of all the data they're collecting in football now. Every player's step on the field, every impact to the helmet, every rotation of the ball, what each player is doing on any given play. Baseball is typically, okay, where were the players and where was the ball hit?
I think what we didn't cover is when we're doing some of the analytics that gets into the machine learning piece. You're not running these on all 100% of the data set. You're running it on subsamples of the data set to make sure that you are testing. When we get into scale, we want to deploy at scale so we can get a good prediction out of it, but you're not doing it off of all of the data right away.
Yeah, and you need test and evaluation data sets. But again, going back to my bias, it can be really hard because there's sometimes that you're going to try to build something and test it on data that you're not sure you have labeled. You're not sure what the ground truth is. So that becomes pretty difficult.
All right, so we did a couple. Let's do the last one for the analytics is prescriptive analytics. So what should be done? I think in my mind, I always get to the yes-no structure of a workflow. So where I do get something about what happened, what are all the actions that were taken after that, and can I routinely do that, and what should be done in the future? So leading into the automation, that's how I feel about the what should be done.
I think the interesting thing here is it doesn't necessarily, you say automation, and this doesn't necessarily mean that it's a higher level analytic than we just talked about. It's just a different type in the fact that you're going to take an action. And it doesn't mean, automation doesn't mean artificial intelligence. Now, you can chain these together. Like I said, an app is one or more analytics put together with a custom user interface. You start talking about like SOARs. So if you've got a security orchestration automated response tool, what you have is you have something happens on the network. Maybe it creates a ticket. Maybe that ticket gets shown to a user. That user clicks a button and an action is taken. It updates the ticket. It's a great way to go because there's traceability in your actions. Or maybe it takes an action and then updates the ticket because it was so severe. I think the easy example to walk through is like vulnerabilities on computers. So if you're on a network, chances are your company knows there's vulnerabilities on it. Because at any given time, there's too many to do the change management and make sure you're not going to break everything if you try to patch every vulnerability at once. So then you start doing kind of this risk analysis of, okay, are these really that important? During that risk analysis, you can start automating some of those things like, okay, does this computer have a CVE on it? Okay, that CVE has a HBSS, that's not HBSS, it's a, what's the score for the CVSS? See, there you go. What's the CVSS score for that particular vulnerability? Okay, it's a 10. Oh, that might be a priority. Does it have a known exploit available? Based off other data I can bring in, one of the data elements from the CVE database, wherever I found it out, is there an exploit available for that CVE? Yes. That just moved up to the top of the list. But hey, let's say that now I have information on my firewalls and I can be like, hey, as we scan our own network, can I see that computer with that CVE that is exploitable from the outside internet? Then the answer becomes yes. You're like, right now, that one's getting quarantined or that one's getting patched. No questions asked. Doesn't matter even if it's mission essential, that one's getting passed. Okay, great. It's not visible from the outside, but it's still a high priority. Is it a mission essential server that can't go down? Is it running someone's life support because it's a OT device in a hospital? Or is it responsible for making sure the Roomba goes off? Okay, that one's getting patched. If the Roomba doesn't go off, no big deal. If life support ends, that's not something we're willing to accept. So as you come on these things, it's this yes-no decision tree of actions, and you decide where the risk is, which things can be automated as you go through and you answer the questions, which things can't be, which things can be automated, which means that a person gets queued and gets to decide, and then the action gets automated. I think that's all fair game, but it all starts with kind of those simple descriptive analytics. Hey, this is the situation. And then you start putting some subject matter expertise to that and doing these decision trees. And I think you can get a lot more advanced without a lot more advanced analytics that happen. And you just need that subject matter expertise to chain them all together.
Yeah. I was thinking about going back to the what should be done. I was ordering some stuff for Code of Entry from Custom Ink. And then every email I got from Custom Ink, it was go check your spam folder. And that's what should be done is things that are hitting your spam folder are going there for a reason because there's some sort of attribute that's being automatically looked at that it should go and it needs to be in that spam folder because it's going to help protect your emails. Like everybody's email, I don't know how many email addresses you have, but I definitely have a spam email that I sign up for everything on. I have one that I use for like family and friends, and I have one I use from like professional perspectives.
This is explaining why she never responds to my emails right now. Okay.
I'm the person that you see with the 45,000 plus emails unread type of thing because of how many.
Yeah, that's my primary email. It looks like that. I don't look at the spam one.
But there's a lot of things that you take for granted already that are already being done, like what should be done. That's already being done. But realizing, oh, I would have been waiting and looking at my email, my normal email for my custom ink order, and it just wants me to validate what the proof looks like. You're like, please go check your spam. You're like, thank you for directing me to go check my spam. You already know what needs to happen and what should be done because everything else that's trying to protect me from anything on the internet is being done for me as well.
Yeah, email deliverability is a different rabbit hole we can go down into on another podcast. But yeah, it's
like
very interesting.
Just thought I would give a current example of like how everybody is already having that enabled for them. It's just whether or not they realize it.
The mail flows, right? You sign up for somebody's mailing list or you sign up for an online class, you get an email that looks like it's from a person a few minutes later. Hey, this is This is Greg. Thanks for signing up. Let us know if you need anything. And then the next one day later, you get that dripped email. Hey, this is Greg. Have you done your day one task yet? Hey, this is Craig. We've noticed you haven't logged in yet. Hey, this is Craig. Here, you can click unsubscribe if you want, or buy this stuff. Thanks.
Buy this stuff, yes.
Yeah.
So bridging off the analytics moves us more into the machine learning piece of it. I don't know that can you describe what's that line that basically transforms you into I'm in the machine learning area now? From what I have, like from normal definitions, it's going to be something that with minimum human intervention, things are identified, there's some sort of pattern, and it can help provide these more predictive capabilities to decision makers if you can personalize it or make it more supportive to them.
Yeah, I think first and foremost is the caveat that machine learning is not synonymous with AI. So a lot of people are like, we need some of that machine learning, and they really mean quote unquote AI. Let me make sure I get this right. So machine learning is basically a square and AI is a rectangle. So machine learning is a subset of AI. So when you start looking at it that way, not every problem is necessarily appropriate for machine learning, but you might be able to solve it with AI. So it's one of those requests, and we started merging the term like, yeah, AI ML.
Yeah.
Please no. And the other thing is, you don't necessarily need AI ML, right? Hey, 2 plus 2, I can probably solve that with addition. I'm sure we could make some convoluted model too.
You can put it into Excel spreadsheet.
I can put 2 plus 2 into Excel, and then I can link it dynamically, and then I can make it equal 4, and then I can paste it as values in another sheet so that it doesn't change. We can overcomplicate some stuff as much as we want. So that's the machine learning thing. The next thing, whether we're talking AI or machine learning, I think that people need to understand is you can't predispose what you're going to learn from it. So the idea with machine learning is you're going to feed data to it and let it take a look at information and come up with assertions that you might have missed. So if you start think about a person, and I'm like, hey, all I really need to know is height and weight, and we can build them the perfect suit. Height and weight, perfect suit. And we start collecting height and weight, and we send it to all these great models of, hey, what should this person's suit style be based off height and weight? And they keep coming up with, wrong. We start getting bad customer reviews. It turns out that we also have information like arm length and neck size and arm circumference and thigh circumference and calf circumference and inseam length. And you start putting all that data together. Shoe size, ring size, hat size, eyeglass size, whatever. The more information you can feed it, you might find out that, hey, guess what? The weight part wasn't that important. These other measurements are much more accurate. I don't need to know their weight. I just need to know that their inseam is this long and their arms are this long and their circumference measurements are like this, and we can do it perfectly. So predisposing what an analytic needs can get you in a lot of trouble because then you just don't collect the right information. And that kind of comes back to last time we were talking about getting more data than less data. If you get less because you're making a human assumption based off what you know that something's not important, you could miss out on what an analytic can learn. You can also make yourself vulnerable to whatever the next big thing is because the piece of information that could now point out the new thing you decided to dump on the floor from before.
I think the piece you talked about was your description in the beginning is you pre-identified what key features you thought would be part and valid for whatever you're trying to do as your end state.
Yeah.
And the whole point of trying to map out all of the different data attributes is to find those features. And if you could do it with a machine in comparison to with human bias, that's helpful to start out because we all have some sort of inherent bias. So having in as many columns, rows, features that you possibly can, and then you run it through to find what are the features that are most interesting to help answer the question.
Yeah, because feature engineering is an art. So the better you are at feature engineering, the more optimal your analytics will be. So they'll run faster and be more accurate, most likely. But if you start with a limited set of features without doing the analysis on the features first, you're going to miss out on a lot. So the first step is, hey, cast that wide net and then start cutting things that are shown mathematically not to be relevant, not things that you thought were irrelevant.
Right. All right. I have a couple things related to We didn't really highlight minimal human intervention. Can we talk a little bit about, I guess my focus would be if I'm running a model, I want the model to be able to run without me having to push a button or without me having to approve, disapprove pieces of the workflow as the script is running. So the outcome is still going to be not dependent on me or another human to say yes or no. That will be a little different for supervised pieces, but
Yeah.
we'll talk a little bit about.
So if you have a model that is already high confidence, I think the state that you're talking about are maybe people that are retraining or special folks that have been put in the loop to continue to update analytics to make sure they don't age. But the average user, if you don't want human intervention, it just needs to work. But that means in the background, you need someone retraining it. It needs to be retraining itself or have a person retraining it. If that model is going to stay accurate, it's got to continue to retrain because stuff can change over time. And you don't want that model to drift from something you have confidence in to something you don't have confidence in. Yeah, but on that side, like there's not a reason once you get a model and it's confident, say that you have a bunch of false positives, but what you're monitoring for is so important it doesn't matter. Then it's not a big deal. Say you have no false positives. Great, let's run it. So I think it becomes a decision on automation versus automation. Automation being, hey, something just keeps happening. We're in the groove. We continue to re-update. We have a CI/CD pipeline and a MLOps pipeline. So our analytics are going to retrain every time there's an update to the app. We're going to deploy it all together. It's going to be perfect. Hopefully we have a pre-production environment to make sure it doesn't crash everything. But yeah, I think that's all part of the more mature ecosystem you have. So you would start with some data in Excel, then you would start with some data in a database. You'd start using Jupyter on it and some R or some Python. Then you would graduate to, okay, we need to do some real development, have a CI/CD pipeline. Oh, we need an MLOps pipeline. And I think you graduate to this ability, because even in descriptive analytics, you might want the ability to have an update, right? So have a cron job that updates the data every 24 hours. So when you come to work at 8 o'clock in the morning, you're looking at today's new picture. I don't think that's necessarily limited to just those higher tier analytics. It's just, what is your use case? How fresh does the data need to be? How fresh does the result of the analytics need to be? Start first with cron jobs. When you get towards models, have that model continue to retrain on fresher and fresher data. Have that model continue to give you results on fresher and fresher data. And use people sparingly so you don't lose their attention. But the other reason is, a lot of times on these high volume analytics, you're doing them because you don't have enough human cycles. I've got 10 analysts and 3 billion events coming in. I want them to look at every event. Literally impossible. Then I start doing these analytics and I'm like, hey, I want them to click yes or no 10,000 times a day. Like, okay, that's much more manageable. It's still not going to happen. So you just have to figure out in the tier of things, what things are important enough for a person, what things are good enough to just leave at the automation level, and then what things could be emergencies that you just have to go ahead and bite the bullet and be like, hey, I'm not as confident as I would like to be, but this would be catastrophic. Let's take care of it.
I think one of the items is, say you only have a certain amount of human capital available. And if a tool is advertised to be able to automate some of that piece that allows the human capital to focus in on the higher priority or higher things that pose a risk, those are always, I think, conversations and course of action decision points for a senior leader to have, where if you pay for this particular tool, maybe you will be able to afford the opportunity for the folks that you have on staff to be able to answer those harder questions when the basic questions could be answered by the tool. And yes, that tool will need to have updates, right? You can't just buy the tool and leave it go for 10 years without any updates, because it'll be an aged type of machine learning model, not be detecting the newer thing.
Yeah, and that kind of leads itself towards maybe having a way to evaluate if tools can do what they say they're going to do. And that's, again, a whole nother can of worms. But the next part of really data literacy is, do the tools that say they do things with data do what they say they're going to do? Because you'll have all the time have vendors show up, be like, yeah, buy this, we'll solve all your problems tomorrow. And the caveat is, we'll solve all your problems tomorrow if you start collecting all of the data and paying to store it all and reformatting it the way we want you to do and sending it to us and paying us more to put it in our cloud storage layer. And then we'll run these analytics. And then after a year or so, we'll go around the world and we'll make sure that all your people are trained. and then a day later we'll solve all these problems. It's like, wait, that's not what you said. Oh, is it not? We said a day later, ... I think that's part of this, and just what is the reality? How do tools deliver, and on what timeline do tools/products deliver? I know Veritech is working on a product that will allow you to give a score to tools based off a data set and saying, hey, you said you could do X, we gave you a score of 80. But right now, the score on that same data for the task you said performs a 90. You've been dominated. Congratulations, go home. That would be interesting to see how that turns out.
It's having the right talents, folks that can check on the type of capabilities just to make sure if it is unique, that sounds great. I'm happy that it's unique and it could be valuable. Is it affordable? Can you get a good return on investment? All of the things that go into I think the DoD isms are, is it written in the scope of work to get the updates that you need? Have we thought about that up front, knowing that software does have cycles that they need to do updates on? They may have vulnerabilities in the future that will need to have updates. So thinking of it from that lens, it's a little different than I bought something, I no longer have to worry about it. I just have to maintain it. Nothing bad will happen to it. I'm just going to have to maintain it. When it's just, that's not really true on things that you want for automation or AI.
Data ownership, training, retraining.
Yeah.
Just performance of what you think you're buying. Yeah.
Running it through.
Not the training of analytics, the training of the people. How intuitive is it? How are you going to field it? Where does it get fielded? Yeah.
What's the barrier to entry for it? The type of individual that can be able to perform the functions. Is this made for a data engineer? That will be a different type of hands-on experience than it would be for a data scientist. Their expectations will be different. They'll use the tool differently. They may expect the tool to do X, Y, or Z, but we didn't pay for that package.
Yeah.
Okay. You did highlight a little bit about the data privacy. So we're going to shift into another concept just related to privacy and security of the data. I think what we've done historically has been, I think, security first approach is like the very first language that we would say when we were having conversations, because we know it's important for the type of field that we were supporting in the past. Privacy whether it's on the European side with GDPR, or we're also talking about HIPAA, that's more prevalent, I feel like, in the more industry community. Although they want to secure their data because they don't want any breaches, there's all these other things to take into consideration when it comes down to policies and adhering to the policies so that something isn't used improperly. And there's a lot of all-domain use cases I've seen so far that are really governance first. They want to make sure the data is secure and that it's utilized properly to the folks that are required to have use of it, in comparison to making it available. It's opposite of that Vaultus principle, like accessible, but it's the accessible to the folks that need to know it. But if you could be as transparent as possible and then still securing it, we want to make sure it's secure against unauthorized access and any or threats. Any thoughts on how do you protect all of that data, but still have that balance of making it available so that you can actually have good value out of whatever you're running on that data?
Yeah, I guess first you go back to, we used to always say, hey, this is a data first approach. A security first approach. And then we changed to a data first approach because people started arguing less about security because they're like, oh, you've got that. And then we went from data to decision first, data focused, right? The terminology's changed. I think that first acceptance, when you can get in and you build education, you build literacy. Like, we had a platform that had this security first mindset. So a lot of those security questions, you used to call them those conspiracy theorist questions, like, you'd answer right out of the bat. But I think if you focus on attribute-based access controls, you can't go wrong. So start storing your information and applying security controls to it the way you would if it was the most secret thing you'd ever touched. Because then the drawback is, okay, I either didn't put enough attributes on it or I need to put less attributes on it. That becomes your accessibility conversation. It becomes that governance conversation. So if you build it with ABAC first, then I think what happens is the governance can catch up. And we always had this, we were far enough forward that we never got slowed down by governance, but we also took this kind of intelligence community mindset to protecting the data. So even before people cared who could see what type of network traffic in the Army, because everybody was in the Army, we were starting to put controls in place. We were making these cell blocks to our data jail that were logical. You start looking for things like HIPAA, like there are very well-published rules for HIPAA. What you can start to do is you put attributes in place, and as you miss something, you add it, and then you just have to go back and add it to the users that are supposed to see things. So I think if you focus on the attributes you want to use and then be able to pair people to those attributes for access, whether you want to make your own local LDAP that does it or you want to integrate with something like an industry best like Okta to do it, it's pairing your security controls to your data with the people that can get access. Then there's one other caveat, or maybe two. It's not always people access to the data. It could be programmatic access to the data. So which applications can see what data and which applications that power users are seeing are allowed to see what data. Because at some point, you're going to have to let your data scientists see some potentially sensitive information so that they can build the analytics. But you need to make sure that it's protected through, hey, this sensitive information got to this app and a person that's authorized to see it made it, but then it could potentially be shared with someone that's not authorized to see it. But it all comes back to ABAC. Every cell basically ends up having this multiple cells of a key, and you have to have every key to get to the one cell. It's like this multi-pointer space where every pointer has to be there to point to one piece of information. If that's going a little too deep, just think of it as like the reverse of your normal Excel document. Normally, hey, I want to go to row 32, and then you can see everything in row 32. Flip it on its head to where you need every piece of information in row 32 to know that it's row 32. If that makes sense.
So one thought for leaders, whether on the government side or in the industry side, is when someone's gonna, if you're talking just legal to the legal personnel, and you need to be able to have your folks describe the system, they need to be able to describe it accurately and how it's securing the data, how it's protecting privacy. I
Yep.
know we're saying we've been fortunate enough to have systems that have been built with that mindset, but there are systems that are out there that aren't built with that mindset. And if you can't
Yep.
answer
Yep.
those questions for folks that are helping to, on the legal side for review or on the leadership side to make sure the program is running as it should, that's a large thing for consideration, that maybe the solution that's been provided isn't the right solution if that can't be described. And I say that because on the data literacy side, securing of the data, that security piece and how you are doing it is something that always comes up. It's one of the
Yeah.
first questions, right?
And encryption is a big thing, but it goes way beyond encryption, because one of those, again, I'll say conspiracy theorist things is, what if someone gets your credentials? Then the encryption's no good anymore, depending on how they get in. So encrypted at rest, encrypted in transit. But the other piece, right? So I start talking about this kind of attribute-based access control. If you start looking at something like Accumulo, this HDFS distribution that was made for security and open sourced by NSA. So if you start looking at something like Accumulo, all these pieces of information in that row that are pointers, the easiest way to explain how this works, there will be, in some of our data, there's 3. In some of our data, there's 20, maybe more. Each one of those being a pointer, I can get to explaining the difficulty in this very quickly. 2 would be, one would be a latitude. One would be a longitude, one would be an altitude. So you would need to know the latitude, longitude, and altitude to see, say, a plane. That would be a piece of data. But then the next one is time. Okay, so you could look with 3 other pieces of data at that spot, and unless you were in the millisecond of time that plane was at that long an altitude, you would never know there's anything there. And that's how a lot of these data systems are made when you start doing these attribute-based access controls. You miss one coordinate, you miss one key, you're out of luck. Okay, great, I have the time, but I don't have the altitude. Good luck. I have the altitude and the time, I don't have the latitude. Good luck. And that's a very low dimensionality example for how the data is really stored and a structure of the database.
So I was thinking a little bit about, from the all domain perspective, the biggest piece is, I think, having some of those attributes available on like the connection to the governance side, so that there is a way to have a good known database where there are data sets available. It is protected. It shows how it is protected. It won't tell you the information, like all the data points inside of, say, that schema, but the schema is at least available. And that is something that can
Yep.
help bridge in between, where you're developing these different things, or you need to talk to industry to help solve those harder problems if they have good models that are cutting edge that you can bring to the data. If they know what the schema looks like, that's helpful, but it's still protecting the data inside of it.
Yeah, I can tell you the schema all day. I can document the API and give you access to how you would get to all of the information. But without the authorizations, you have no idea what the data itself is. Yeah.
Any thoughts on best methods of testing your types of data platforms to show security or show that privacy? In my mind, it was easier for me as a user to be able to test without having someone on the sysadmin take away my roles. You talked a little bit about the attributes, right? Any tips or tricks for an equivalent senior leader that would need to be checking attributes? How could they check it? What's the great questions they should be asking for someone on the industry side?
So if we're not talking necessarily security of the system, like infrastructure wise, but user wise, I think what you start looking for is, hey, I'd like to see a user list. Give me a list of all the attributes. Give me a list of, and if I go specifically, you should have these visibilities to control what people can see. They're not necessarily a real security layer, but it's what your average user can see. It's for ease of use and stuff like that. Then you have roles, which is what are they authorized to do on your system? How are they allowed to interact with it? And then you have the actual security layer of these authorizations. What you'd need to look at is, okay, how are these all paired together? How are they built together? Hey, give me a user list. And how many users have this trust? We used to have one that was a defensive cyber operations was an auth, DCO. If they were on a mission, they had a mission auth. And then if it was something very special, we would put like a trusted agent authorization on it, right? Hey, how many trusted agent authorizations do we have? It's like, oh, we have 73. We have 73 trusted agent authorizations. How many DCO authorizations do we have? 73. How many missions? 73. And you'd be like, all right, look, everybody, just because they've had it before, because they were on something, doesn't need to keep it. Or just because they might deploy on a mission tomorrow that might be special doesn't mean they need it. So you have to be familiar with how you're tiering these authorizations to get more and more restrictive and ensure they're actually restrictive. Yeah, apply them in a common sense manner. You don't have to be secret squirrel about who can see what, but you should have job roles mapped to different authorizations. And then you should always have an extra layer that you can put on just in case there's a reason that you need to be even more sensitive about something. If it's already in the system, it's easier to go ahead and apply it. And you can chain those authorizations. So because it's that kind of pointer system, you can continue to change them. But I think the real thing to look at is just say, hey, what roles do we have in our organization? Like, what do people do in the organization? What types of data do we have? Okay, let's make sure each type of data has an authorization. Let's make sure each role has an authorization and determine which combinations of those can see what. And that really helps you get towards that granular level of access by also knowing that you can give anyone access that needs it. Because it's not necessarily about, I'd have to re-ingest the data, I'd have to do something special. No, I just have to make sure the right people have the right authorizations to the data they need to see.
So what I'm hearing is on a programmatically, if you're in charge of something like this, it's a routine audit.
Yeah,
auditing how folks, not just from that perspective, from the security of the data. You're looking at the roles, looking at whoever has access to it, auditing metrics wise, how many consumers are actually using it. It gets you different metrics back, but a healthy audit is basically required to help run and sustain the program, especially when it comes down to just legal and compliance. So you can't forget about that part.
Yeah, and on the non-data side, this is a softball, but on the non-data specific side, it's also making sure that your admins are using a VPN to come from a single IP, using multi-factor authentication to get into the backend. You need that extra level of security. So make sure you have this whitelisted IP with multi-factor authentication coming in to do admin access. And then for the average user, it has to be multi-factor authentication. You don't want folks to be able to try to brute force password and get in, because even if I only get in as an individual and I can only export what Greg Bew was allowed to see, I can still export information.
Right.
So it's, no username and password only. We need multi-factor authentication into the system to get data. And I think that's your bare minimum for users. You can then start to do stuff like impossible logins, and blocking people if they try to log in with the wrong password and freezing them out to make sure you can't rotate through IPs around the world and whatever. But at the basic level, it's multi-factor authentication, whitelisted multi-factor access for admins.
Good tips and tricks.
All right. So what's up next time?
For our next broadcast, we'll have data integration. We'll do some cloud management, at least from the data perspective. And we'll close it out with what we started with, which was how do you get to that decision point? What does a data-driven decision look like? Yeah.
Awesome. Sounds fun. We will see you back here next week. Hope you enjoyed. As always, like, comment, share, subscribe. Let us know what you're thinking and what we can do better. Till then, keep hustling.
Thanks for listening. Find us on social media at Code of Entry and online at codeofentry.com. Check back for new episodes or join the team by signing up for notifications. Until next time, keep hustling.